Hello, in this video we will talk about the sum and the difference formulas of angles of cosine and sine and tan. So before going ahead, let's solve some problems. Okay, so first of all we will have alpha angle which is 60 degrees and beta angle which is 30 degrees. We have to check whether if we add the angles together and then apply the cosine function on the angle, or we apply the cosine function on the first angle, we apply the cosine function on the second angle, and then we add, whether we get the same answer or different answer. This is what we have to check. Okay, so first of all I will count this, what is this, and then I will calculate this. Okay, so here cosine of alpha plus beta equals cosine of alpha equals 60 degrees plus beta equals 30 degrees. So first of all I have to add the angles. You know 60 plus 30 equals 90 degrees. And if we calculate cosine of 90 degrees from the calculator, we will get 0. Okay, so the left hand side gives you the 0 answer. Now I will check whether this side also gives me the 0 or something else. So let's calculate this thing. Now we calculate cosine of alpha plus cosine of beta, which is equal to cosine of alpha is 60 degrees plus cosine of beta is equal to 30 degrees. If we find the value of the cosine of 60 degrees from the calculator, it will give me 1 by 2. If I find this value, cosine of 30 degrees, I'll get square root 3 by 2. Now, if I add these two things, because my denominator is same in both of the fractions, so I can write the common denominator and I can add this and this, both of the numerators. So my answer is 1 plus square root of 3. So that means cosine of alpha plus cosine of beta equals this number, which is not equal to 0, but previously cosine of alpha plus beta was 0. So which means that this thing is not equal to this thing. That means we should write they are not equal. Okay, so that means this is not the correct way to calculate the sum of, to calculate the cosine of the sum of the angle. Okay, so that means we need this formula that if I apply cosine of alpha plus beta, then what will I get? We need the formula in terms of cosine alpha, cosine beta, or any trigonometric ratio involving alpha and beta. Okay, similarly, if you check sine of alpha plus beta equal, okay, and sine of alpha plus sine of beta, will you check whether they are equal or no? So let me check this one also. Let me find first sine of alpha plus beta, which is equal to here sine of alpha plus beta equals sine of 60 degrees plus 30 degrees, which is equal to sine of 90 degrees. Since sine of 90 degrees is equal to 1, so my left hand side is equal to 1. Now I'll calculate whether this is also 1 or different. Now sine of alpha plus sine of beta equals sine of 60 degrees plus sine of 30 degrees, because alpha is 60, beta is 30. If I calculate from the calculator, it will give me square root 3 by 2 and it will give me 1/2. If I add them, I'll get 2. 2 is the common, so the common denominator will be 2. Then I'll add the numerators, which is square root 3 plus 1. Again, sine of alpha plus sine of beta gives you this number, but sine of alpha plus beta was giving you 1. So that means again both are not equal. So I will say they are unequal. Okay, similarly, if you check the same thing for tangent of the alpha plus beta, tangent of alpha plus beta equals, okay, we will check whether it is equal or not. Tangent of alpha plus tangent of beta. So let's calculate first tangent of alpha plus beta. So if I calculate this value, I will get tangent of 60 degrees plus 30 degrees, so which is equal to tangent of 90 degrees. But tangent of 90 degrees equals to, is undefined, which is sometimes we write infinity. So this is infinity or undefined, whatever you write. But if I calculate tangent of alpha plus tangent of beta, it is equal to tangent of 60 degrees plus tangent of 30 degrees. This is equal to square root 3 plus this is equal to 1 by square root 3. If I take, okay, by the way, this is not equal to infinity. Okay, since the previous answer was infinity and this answer is not infinity, so again they are not equal. So you can say that this is again not equal. So we need all of these formulas. So in this video we will try to find the formulas for cosine of alpha plus beta. We need the correct formula because we know that it is not equal to cosine of alpha plus cosine of beta. It is not equal. So what we need, what should be here? Okay, we will find what is equal to cosine of alpha plus beta. Similarly, we will find the formula for the sine of alpha plus beta and the tangent of alpha plus beta. So here we will prove that cosine of alpha plus beta equals cosine of alpha cosine of beta minus sine of alpha sine of beta. So in order to prove this formula, we will make two angles alpha and beta in on the complex plane. Okay, so first of all, I will make one angle here and one angle here because we have two different angles. So it's easy to make one angle here. For example, this is my beta. This angle is beta, and suppose this angle is of measure alpha. Okay, so because this is in opposite direction, so I will call it negative alpha and I will call it beta. Okay, but the measurement of this angle is alpha and the measurement of this angle is beta. This is negative because it is in the down direction, and this is positive because it is in the up direction, or in other words, it's in the anti-clockwise. Usually anti-clockwise angle is positive and the clockwise angle is negative, right? Because if you see, this is going towards clockwise, right? So clockwise angle is always taken negative, and the anti-clockwise is always taken positive. But if you measure this whole thing, it is, so this one is alpha, and this one is beta, and this one is of measure alpha. So the whole angle is alpha plus beta. Okay, because the measurement of this angle is alpha, and the measurement of this angle is beta. So this whole angle is alpha plus beta. Moreover, I have drawn this unit circle. Unit circle means this is the circle whose radius is 1. Okay, so I have drawn this unit circle intentionally. So first of all, we will provide the name to each corner. For example, this central corner is O, and this point where this angle alpha is cutting the unit circle is P, and this point, for example, Q. So this is our complete setup. Okay, so now I will make a similar setup just like this one, but when I have to calculate this everything, this line or this line must be standard. What is meant by standard line? Standard lines are either x-axis or y-axis, right? So I need the reference lines to be standard, right? So how can I make this reference line as a standard? I can rotate it. So in this way, I can rotate the whole system. So that means if I rotate this thing this way, then I have to rotate this thing this way, such that this line just coincide with x-axis, right? So why I'm going to do this? Because I need this line to be standard, right? So that I can have standard measurements. So because this measurement is not standard, here you have negative alpha, here you have plus beta. So this measurement is not standard. So I want to make it standard. So if I rotate this whole system, then what will happen? So it was my original diagram, original setup. Now what I have done, I have rotated this line to this line and this line here. So when I rotated this line here, I got this line. When I rotated this line here, I got this line. So suppose this line cuts here at S point, and this line cuts here at R point. So now in this case, this whole angle is alpha plus beta. Because this whole angle was alpha plus beta, so now this angle is the same because I have rotated everything. So alpha plus beta will remains unchanged. Okay, now if I draw this triangle here in this diagram, I have this thing, and similarly if I draw the triangle in this diagram, I have this thing. Okay, so we know that this angle is alpha plus beta. Now in order to deal with this kind of setup is easy, because this line is standard along the x-axis, so I can deal with this kind of diagram easily, right? Now since we have the complex plane, this is also the complex plane, this is also the complex plane. Okay, so and I have told you that this is the unit circle, so that means its radius is 1. So this whole length is 1. So we can write the components of each of the point. For example, the component of point P are cosine of negative alpha plus iota sine of negative alpha. So in other words, cosine of negative alpha, comma, sine of negative alpha, right? Similarly, the components of this point are, because the angle is beta, so I will write cosine of beta comma sine of beta. Okay, so I have the components, in other words, the coordinates of both of the points. And here also I can have the coordinates of S. You know the coordinates of S are only 1, 0, 1 comma 0. Otherwise, you can write the coordinates of S are cosine of 0 comma sine of 0. Cosine of 0 is 1 and sine of 0 degree is 0, because this is 0 degree angle. Similarly, the components of the coordinates of this R are equal to cosine of the total angle is alpha plus beta, cosine of alpha plus beta, and sine of alpha plus beta. So these are the coordinates of each of the point in these diagrams. But if you look in these diagrams, everything is similar. If you look at the triangle, for example, if you look at this triangle here, it is similar to the triangle which you can see in this diagram. Why? Because this length is 1, and here you can see this length is 1. Why they are 1? Because I am using the unit circle. In the unit circle, the radius is 1. Okay, since this length is the radius of the unit circle, therefore it is 1. And this length is the radius of the unit circle, so this is 1. Similarly, this length is the radius of the unit circle, so 1. So this length is the radius of the unit circle. So these four lengths are 1, which I have marked with red. So they are 1, so they are equal. So we can say that these four lengths are equal. Okay, so what about the third length? This length is equal or no? We don't know whether this is equal in both or no. We can make an argument that they are equal, but we have to prove it. How can we prove it? So we know if we have two different triangles, this triangle and this triangle, I should make them similar just like they are. So if this length, this length, this length, this length are equal, and this angle is also equal in both of the triangles, then we can say that the third length is also equal. So if three things are equal, that means everything is equal, because this is one thing, this is another thing, and this angle is third thing. Because these three things are equal in both of the triangles, so that means in both of the triangle everything is equal. If everything is equal, so that means this length and this length is also equal. So that means we can say that the length with blue marked line is also equal. So that means these two triangles are equal in both of the diagrams. They are similar. So if they are similar, that means the distance from P to Q is equal to the distance from P to S. I think I have to change this point because both cannot be P, so I have to write this R. Okay, so what I have said that this length is equal to this length. That means the distance from P to Q is equal to the distance from R to S. Okay, so I will write the same thing, but in mathematical equation, right? What I said the length of PQ, I mean the distance from P to Q, the distance of Q from P is equal to the distance of R from S. Okay, so I can square both of the distances. Okay, if I apply the formula for the distance square, so I know what is P and what is Q. Here P is equal to what? We know what is P and we know what is Q. P is cosine of negative alpha. You know the cosine of negative alpha is cosine of alpha. So I will write P is equal to cosine of alpha. But cosine of negative, sine of negative alpha is negative sine of alpha. So I will write here negative sine of alpha. So this is the property of cosine. Whenever anything negative comes in its angle, in the angle of cosine, that thing gets turned into positive, right? But if something negative comes into the sine, into the angle of sine theta, then that negative comes in the front of this function. So that means this P is equal to, this P has these coordinates, and then look, what are the coordinates of Q? The coordinates of Q are cosine of beta and sine of beta. Let me write cosine of beta and sine of beta. Okay, so if I have to find the distance of P and Q, then I have to use these points. Okay, this point is for example x1, this point is for example x2, y1, and this point is x2, and for example this is y2. Then the distance from P to Q is equal to y2 minus y1 square plus x2 minus x1 square and whole square root. Okay, so if I put the values, what is y2 here? Here y2 is equal to sine of beta, so I will write sine of beta minus y1. Here I should write y1. What is y1? y1 is minus sine alpha. So I will write minus sine alpha whole square, right? Plus x2 minus x1. What is x2? x2 is cosine of beta. I will write cosine of beta minus, I will write x1. So x1 here in our case is cosine of alpha. So I'll write cosine of alpha. Okay, so I have found PQ distance, but I need PQ squared. So if I apply square on both sides, here I will get PQ squared. And if I apply square here, you know, if I apply square here, this square will cancel with square root. So that means I will have the same thing but without square root. Okay, sine of beta minus sine of alpha plus cosine of beta minus cosine of alpha. This is PQ whole square. Now I will find what is the distance of R from S. In order to find this distance, I have to write the point R and the point S. You know here, now the coordinates of R in this diagram are cosine of alpha plus alpha plus beta and sine of alpha plus beta. I'll write cosine of alpha plus beta and sine of alpha plus beta. And similarly, the coordinates of S are 1 and 0 from this diagram. Okay, so in this, again, this is x1, this is y1, this is x2, this is y2. So again, I have to find the distance of R and S. So the distance of R with S is equal to y2 minus y1, the same formula, square, plus x2 minus x1 square. If I plug these values, we know y2 is equal to 0. I'll write here 0 minus y1 is this one, which is sine alpha plus beta, but this is squared, plus x2 minus x1. What is x2? x2 is 1, so I'll write here 1 minus x1 is the cosine of alpha plus beta. But everything is squared inside, so I have r comma s, which is equal to this distance, but I need rs square, so I will square both sides. Here on the left hand side I'll get rs square, but here I have already square root. If I apply square, that means I am killing the square root. Okay, since I am killing the square root, I have everything but without square root. So this is just nothing but 0 minus, so 0 minus sine of alpha, so I have minus sine of alpha plus beta whole square. 1 minus cosine of alpha plus beta whole square. Okay, so if I apply this square on minus, the minus will get killed, so I will have sine square of alpha plus beta. If I apply this square here, I will have a minus b whole square. So what is a minus b whole square? A minus b whole square is a square minus 2ab plus b square. So here my a is 1, b is cosine of alpha plus beta. So I will write a square means 1 square. Okay, minus 2ab, I'll write minus 2 times a is 1, b is cosine of alpha plus beta, plus b square means cosine square alpha plus beta. Okay, so if I simplify, I have sine square of alpha plus beta plus 1 minus 2 times cosine of alpha plus beta plus cosine square alpha plus beta. You know, sine square plus cosine square of the same angle is equal to 1. Okay, this plus this is 1. So I will write instead of this and instead of this, I will write 1 plus these two terms. These two terms are 1 minus 2 cosine of alpha plus beta. So I have 2 minus 2 cosine of alpha plus beta. Now I have rs square also. I have pq square also. So I can equate them because from the triangles I have proved that this distance is equal to this distance. If the distance is equal, that means their square must also be equal. So now we compare them. We can write PQ square is equal to RS distance square. What is PQ squared? Distance of PQ squared. This is equal to this thing. So I'll write this is equal to this one, and this is equal to RS square is equal to this thing. So I'll plug this value over there. So I have this equation. Okay, since this side is already simplified, I have to simplify this side also. Again, here I have a, here I have b. A minus b whole square, again I'll apply this formula. A minus b whole square is a square minus 2ab plus b square. So I'll write a square means sine square alpha minus 2ab means sine alpha times sine alpha. Okay, plus b square means sine square alpha. Okay, sorry, I have made a mistake. Here I have sine square beta because it was sine beta. I thought it's alpha. Similarly, here I have sine of beta, and yeah, this is the case. Okay, so now, so I have done with this square. Now I have to deal with this square. I will again use this formula because in this case, this is my A and this is my B. What will I do? I will again apply this formula. A square means cosine square alpha beta minus 2 times AB means multiply these two, cosine of beta, cosine of alpha, plus b square means cosine square alpha. Okay, and this whole thing is equal to 2 minus 2 cosine of alpha plus beta. Now, since we know previously sine square of the angle plus cosine square of the angle is always 1. If this angle is same, if this angle is different in both, then it is not 1. Now look, we have sine square beta. If I have cosine square beta also, yeah, this is cosine square beta. That means this thing plus this thing is similar to this. So this is equal to 1. So in order to write both of these terms, I will only write 1 because they both will join and make 1. Okay. Similarly, I have sine square alpha, and where is cosine square alpha? Here is cosine square alpha. So they will also join to make 1. Okay. Here these black guys will join to make 1 and the red guys will join to make 1 because they are satisfying this formula. Okay. So here in place of black guys, I'll write 1. And in place of red guys, I'll again write 1. And this is equal to what? Negative 2 sine alpha sine beta, and this is negative 2 again, negative 2 cosine of alpha cosine of beta equals 2 minus 2 cosine of alpha plus beta. Okay, so here I have 2 minus 2 sine alpha sine beta minus 2 cosine of alpha cosine of beta equals 2 minus 2 cosine of alpha plus beta. Okay, look, what was our target? Our target was finding cosine of alpha plus beta. But here cosine of alpha plus beta is not separate. I have to make it separate. Here I don't need this 2. I don't need this negative 2. What will I do? I'll shift this 2 here. When I'll shift this plus 2 here, it will become negative 2. I'll have 2 negative 2. Negative 2 sine alpha sine beta negative 2 cosine of alpha cosine of beta equals negative 2 cosine of alpha plus beta. What I have done, I have shifted this 2 here because this 2 was positive. So here I have made it negative, and everything else is the same. Okay, but if you check, this plus 2, this minus 2 will get cancelled. But if I take this negative 2 common from both, I'll have sine alpha sine beta minus plus cosine alpha cosine beta equals negative 2 cosine of alpha plus beta. If I cancel this negative 2 with negative 2, I'll have cosine of alpha plus beta equals sine alpha sine beta plus cosine alpha cosine beta. Look, what we had to prove, we had to prove cosine alpha cosine beta, which is, yeah, there is negative, we had positive. Yeah, I got where we got mistake. Here we had mistake. Look, we need to put y2 minus y1. So I have y2 is equal to sine of beta minus, I need y1. y1 was minus sine alpha. If I put minus sine alpha, I already have minus, so here I will have plus. Okay, so if I have here plus, then that means, yeah, here I have plus. Then if I have here plus, that means this term will become plus. If this term will become plus, then yeah, that means this term is plus, that means this term is plus, sine alpha sine beta turns into plus. Yeah, if this turn into plus, then here it will be minus because I have taken negative common. When I will take negative common, so that means here I will have plus, a minus, right? So that means here I have negative. So I will write positive term first, negative term later. So I have cosine alpha cosine beta minus sine alpha sine beta. So cosine of alpha plus beta equals this formula. So this is proved using the complex coordinates of the angles, right? Of the things which are making different angles. So in the next video, we will prove another formula for the sine of alpha plus beta and the tangent of alpha plus beta.